Group 5. We will now explain mast cell degranulation. First, let's discuss the definition. Mast cell degranulation is a reaction that mast cell receiving a stimulus and release substances such as histamine from within the cell. Explaining step by step. When IgE binds the mast cell, tyrosine kinase is activated, increasing calcium ion concentration, which triggers degranulation and the release of histamine, cytokines, and other substances. Next, we will discuss the biological role. The key substances here are the released histamine and cytokines. First is the initiation of inflammatory response. For example, histamine causes vasodilation and increased permeability. Additionally, TNF-alpha directs neutrophil to the site of infection. Second, it facilitates the rapid elimination of harmful substances. Released histamine induces sneezing, coughing, and intestinal motility. Thus, this reaction enables quick response to dangers. For example, this reaction is seen in anaphylaxis. Anaphylaxis is a rapid, severe allergic reaction that occurs throughout the body. This is caused by allergies such as bee venom or food allergies. First, when these allergies are taken into the body for the first time, immune cells recognize them and present an antigen activating B cells. Then, B cells produce IgE antibodies, which is specialized for allergies. These antibodies then bind to receptors on the surface of mast cells. Subsequently, when the same allergies enter the body again, it binds to multiple IgE antibodies on the mast cell surface, forming a crosslink. This crosslink triggers the degranulation of the mast cells, releasing a large amount of histamine. Histamine causing vasodilation and bronchoconstriction. The former leads to severe hypertension, and the latter causes dyspnea, resulting in anaphylaxis. When I explain the prevention of anaphylaxis, the most fundamental step, avoiding triggers. Before using any medication, the goal is to prevent the reaction entirely. Common triggers including allergies such as pollen and food and environmental irritants, like strong smells or extremely heat and cold. Identifying and avoiding these is key. If avoidance isn't enough, the next preventive step is mast cell stabilization. The mechanism here is proactive. We use drugs to make the mast cell less sensitive. This ensures they don't release inflammatory chemicals in the first place, preventing symptoms before the day starts. A key example is chromoline sodium. However, if the inflammatory chemicals are released, we turn to antihistamines. Their mechanism is to block histamine receptors to stop the signal. The benefit is immediate relief. They quickly reduce active symptoms like itching, sneezing, and hives. For more severe or persistent reactions, we use anti-inflammatory agents. These provide a powerful suppression of the inflammatory response. The key drugs in this category are corticosteroids, with prednisone being a common example. Finally, for the most critical situations, we have the treatment for anaphylaxis, epinephrine. It works rapidly to constrict blood vessels, raising blood pressure, and relax the airways. The standard device for this is the EpiPen. Thank you for listening.